Hi there. Today we will look into ideal gas equations. Before we move on to the equation, let us look into the meaning of an ideal gas. An ideal gas is defined as a perfect gas which obeys the three gas laws, which will be Boyle's, Charles, and Gay-Lussac's, which is also known as pressure law in exact condition. First, let us look into Boyle's law. Okay. So according to Boyle's law, it states that the pressure of a fixed mass of gas at constant temperature is inversely proportional to its volume. So based on the definition, we can sketch a P versus V graph. Okay. So if you observe over here, we have two different temperature where T2 will be greater than T1. Okay. And then from a graph, okay, we can deduce an equation where pressure will be inversely proportional to volume. And when the T is kept constant, then we will end up with equation which will be equivalent to P1 multiplied with product V1, which will be equivalent to P2 times product of V2. So for the second law, we will look into Charles' law. Okay. According to Charles' law definition, the volume of a fixed mass of gas at constant pressure, okay, will be directly proportional to its absolute temperature. So if you observe at the graph over here, V versus T, okay, we will observe a graph where it increases linearly with temperature. But if you look at the definition, it says directly proportional. But the keyword over here, it must be at absolute temperature. Absolute temperature, that means the temperature should be in Kelvin. Okay, so if you plot a V versus T graph where the temperature in Kelvin, then we will get a directly proportional relationship. So this one I will show you at the next law, which will be at the third law. V versus T graph where the T in Kelvin. So from the graph, okay, we can state the relationship where volume is directly proportional with temperature, and when the pressure is kept constant, we will end up with the equation V1 over T1, which will be equivalent to V2 over T2. The last law will be pressure law. Okay. So for the definition, the pressure law states that the pressure of a fixed mass of gas at constant volume, okay, will be directly proportional to its absolute temperature. So if you plot a graph, P versus T graph over here, okay. So now if you observe over here, the temperature is given in Kelvin, okay. So therefore we get a directly proportional relationship, okay. So same like the previous one, this graph can be either plotted in P versus T graph where the unit of temperature in Kelvin, or it could be in degree Celsius. And based on the graph, we can end up with the equation, okay, where the pressure is directly proportional with temperature at constant volume. So therefore, we will end up with the relationship P1 over T1, which is equivalent to P2 over T2. Finally, combining all these three equations, we will end up with an ideal gas equation, where for the equation, PV will be equivalent to nRT, where over here N represents the number of mole gas, and R, which will be the molar gas constant, where the value will be equivalent to 8.31 joule per Kelvin per mole. Okay, that's all for today.